Hi there and welcome to another video from HEGARTYMATHS, a Core 4 Maths A-Level video, and it's the third video on vectors and we're dealing with vector diagram problems. As always, see YouTube, Twitter or Google Plus for more help with your maths. So this is the third tutorial, it's chapter 5, it's vector diagram problems, it's the Edexcel course. So far we've dealt with all the following, okay, so all of these have been dealt with here, and what we're doing now is we're using these ideas that we've talked about to answer some vector diagram problems, okay? Now these can be quite complicated, so I wanted a video separately on these. In theory, you have all the knowledge to be able to answer these from the previous two videos, so you may want to attempt each question without looking at me doing it. Alternatively, if you're getting stuck, do watch and take notes of exactly how I do it. The key to these are you must draw the diagram and label in your vectors correctly before you even start attempting the question. Okay, so let's have a go at the first example. You may want to try this yourself. You may want to watch and copy. We've got a diagram. P to Q is 3A in that direction. Q to R is B in that direction. S to R is 4A in that direction. And P to X is some lots, K is just a number, let's not worry about what K is some lots of P to R. And what we mean by that is that these two are parallel to each other. You can clearly see this one is just a shorter version of PR. So K is going to be some number less than 1, okay? So they're parallel because one vector is a multiple of the other vector, okay? Now, it says, here's the question, find in terms of A and B and K, so K can be in our answers, P to S. So, P to S. Let's firstly write it down in terms of corners. How do you get from P to S? Well, I would go to Q, to R, and then to S. So I would say that is equal to P to Q plus Q to R plus R to S. Simple. State what you're doing before you start jumping ahead. Now P to Q is 3A, Q to R is B, and R to S, now be very careful, you're going that way, so it's negative 4A. Okay, and tidying this up, 3A take away 4A is negative A, so we'd have negative A plus B, but we'd write that as B subtract A. That's the neater way of doing that. So P to S is actually B subtract A, and we're done. Okay, let's move on to the next one. Let's go down the page for now. Let's move this up so we've got a bit more space. Let's go for question B, and we're going from P to X. Okay, now how do you get from P to X? Well, I would go, does it tell us anything about X? It tells us that P to X is some lots of P to R. Okay, it's K lots of P to R. So you know from the opening question that P to X is some number lots of P to R. Now, do you know what P to R is? Well, P to R you can do. P to R is P to Q plus Q to R, isn't it? And P to R is 3A and Q to R is B, so this must be K 3A plus B. Now you may think, yeah, but what is PX? Well, it's said in the question you can leave your answer in terms of K, so we're absolutely fine to do that. Now you should work down usually, I'm just going to do it here so I can stay on the page. Now we want to go S to Q. How do we get from S here to Q? Well, the easiest way in my mind is to go S to R plus R to Q, and S to R is 4A. R to Q is going the opposite way, so be careful, it must be subtract B. And it's as simple as that. Part D, we want to go S to X. So this time, we want to go from S to X here. Now how could I do that? How could I get from S to X? Right, well what I could do is I could, let's say, well, I could do the following. I could go, so s to x, I could go s to r plus r to q plus q to p, and then I could go from p to x because I know what p to x is. Now let's just tidy this up. S to r would be 4a, r to q would be going backwards, so it would be subtract b, and q to p would be going backwards, so it would be subtract 3a. Now p to x, I've already done this in part b. P to x here is k 3a plus b. So plus k lots of 3a plus b. Okay, now let's just tidy it up a little bit. That, take away that, would be a subtract b plus k 3a plus b. As that. Okay, and it's fine as it is at the moment, but actually you should tidy it up in how many a's you've got. You've got 1a here. Well, let's expand this out, sorry, to start with. You've got a subtract b, and then you've got here plus 3k lots of a plus k lots of b. Now the question then is, how many a's do we have? We've got 1 here and we've got 3k here. So if you add them together, you've got 3k plus 1 lots of a. And how many b's have you got? Well, you've got negative 1 here and k here, so you've got k subtract 1 lots of b's. So that's the tidiest way of writing s to x. S to x is 3k plus 1 lots of a plus k minus 1 lots of b. Let's move on to the next section then. Here's the next question. It says, this is the tricky bit, use the fact that x lies on SQ to find the value of k. So what I'm going to do is I'm going to draw a line under the work I've currently done, and we're going to think about this. Now, x lies on the line SQ. This means that s to x, this vector here, must be parallel to s to q. Let's say this vector here. They must be, because they both share the same starting point, and x is on the line that goes to s to q. So these two must be parallel to each other. So I can write that down as a statement. So I can therefore say that s to x is parallel to s to q. Okay, and what does this mean? This means that sx is some multiple of sq. Sx must be some lots of sq, and this is, we can similarly write that sq is some lots of sx, just writing it the other way around. Okay, it depends which way around we want it. Now it is helpful in this case to think of the way around we want it. We are going to use these, this here was, sorry, sq. We are going to use what SQ and SX were to deal with it, and use these parallel facts in order to solve an equation for k. Now, if I said this one equals some lots of that one, okay, or this one equals some lots of that one, either way around it works. It would just be a different lambda, a different alpha. This is the best one to choose in this case, and the reason is we're going to do lambda times 4a minus b. It's going to be tidier rather than doing mu times stuff with k's in it where it's going to be complicated and unwieldy. Let's do it this way around. So sx is 3k plus 1 lots of a plus k subtract 1 lots of b, and that's equal to some number times sq. Okay? Now what we're going to do is we're going to expand this side. So this would be 4 lambda a minus lambda b, and this is 3k plus 1 a plus k subtract 1 b. Okay, and now we've got a similar scenario to that we had in the second video. We've got some lots of a plus some lots of b equals some lots of a and some lots of b. So therefore, because a and b are non-zero, and we're told originally in the question a and b are clearly not parallel, you can see a and b can't be parallel, then what you can write is you can therefore write that the only way this must be true is this, however many a's you've got on the left hand side equals however many a's you've got on the right hand side. So 3k plus 1 must be 4 lambda. Okay? And similarly, however many b's you've got on this side, you've got k minus 1, must equal however many b's you've got on this side, negative lambda. So k subtract 1 must be negative lambda. Okay, these are equation 1 and equation 2. We can solve them simultaneously to find lambda or k. We want to find k here. Now imagine we multiplied this equation by 4 and kept this equation, it's the same, just multiplied it by 1. We'd have 3k plus 1 equals 4 lambda, no change. And here we'd have 4k minus 4 equals negative 4 lambda. That could be equation 3 and 4. And what we could do is we could add these because the lambdas would then disappear. If we added equation 3 and 4, well, 4 lambda add negative 4 lambda is 0, 3k plus 4k is 7k, and 1 plus negative 4 is negative 3, and we can solve this to find that k is 3/7. Now, it didn't ask us to find lambda, it just said find k, and k is 3/7. And there we go, we've solved a complicated problem. Okay, I'm going to do 2 more. Again, you might want to try them yourselves or watch me go through them. Next one. We have a diagram, okay, and it shows the following. And now label your diagram up. Draw this in the exam if you need to and label it up. O to A is vector little a. So O to A, that's vector little a. O to B is vector little b. C divides AB in the ratio 5:1. So therefore this thing here is 5 parts and this thing here is 1 part. Okay? Write down in terms of A and B expressions for A to B, A to C and O to C. So for part A, how do we get from A to C? How would you get from A to C? Sorry, A to B even. Sorry, my fault. Sorry. How would you get from A to B? Well, to get from A to B, you'd go A to O, and then you go O to B. So you go down there and up there, which would be negative A plus B. And we'd write that as B subtract A. Okay? Right, next one. How would you get from A to C? Well, let's think of how would you get from A to C. A to B, the whole thing, A to B, is equivalent to 6 parts. Agreed? So, 1 part, if I just want to go 1 across, it must be 6 of A to B. And if I wanted to go 5 parts along, it must be 5 times that, which is 5/6 A to B. So if I want to go from A to C, it's 5/6 A to B. And we know A to B from the first part is here, so the answer would be 5/6 B subtract A from up here. How would I get from O to C? Well, O to C, the next one, how would I get from O to C? If I wanted to get from O to C, why wouldn't I go, I could go O to A and then A to C, which I've done above. So that's O to A plus A to C. Now O to A is easy, we know O to A. O to A is vector A, and A to C, we've just done it, is 5/6 B subtract A. And we could tidy this up, that's A plus 5/6 B subtract 5/6 A. I've got 1A, take away 5/6 A, 1 take away 5/6 is 1/6, so I've got 1/6 A plus 5/6 B. Okay, and that is how I answer part A. Okay, now I'm going to rub this out and I'm going to move on to other parts. In fact, I might keep that page and I'll just so I can refer back to it. And I'll rub all this out and I'll start this stuff off here. Now, next, we are told, given that OE is lambda times B, where lambda is a scalar, so O to E, this one here, O to E, is sum lots vector B. Now that makes sense because O to B is vector B and this is part of it. So we're saying E is on the line OB, definitely. Write down in terms of A, B and lambda an expression for C to E. So for part B, how do you get from C to E? How do you get from C to E? Well, what you could do is you could do the following. You could go from C to A, and you go from A to O, and then you could go from O to E. Okay? So C to A. Now in the previous part, we've done A to C, which is 5, 6, B minus A. So the other way around must be negative 5, 6, B minus A. Okay? A to O is negative A. And O to E, well, we're told O to E is lambda B. Okay? Now let's just tidy it up, expand this out. This is negative 5, 6, B plus 5, 6, A. Take away A plus lambda B. Okay, how many A's have we got? Well, we've got 5, 6A, take away 1A. So 5, 6 take away 6, 6 is negative a 6A. And how many B's have we got? Well, we've got negative 5, 6B plus lambda. So we've got plus lambda minus 5, 6B. Okay? Now next we are told, given that OD is mu B minus A, where mu is a scalar, write down the following. So O to D, this one here, is now mu B minus A. Write down in terms of A, B, lambda and mu an expression for E to D. So I'm going to rub out this one here. How do I get from E to D? Here to here. Well, E to D, couldn't I go from E to O? And then I could go from O to D. Okay? Now, E to O is the opposite of O to E. So it would be negative lambda B from here. O to E is lambda B, so E to O must be negative lambda B. And O to D, well, we're told O to D, it's plus mu B minus A. Expand it out and tidy up. This is negative lambda B plus mu B minus mu A. How many A's have I got? Well, I've got negative mu A. How many B's have I got? Well, I've got mu minus lambda B's. Okay, and then lastly we're told, given also that E is the midpoint of CD, so E is the midpoint of C to D, okay, it's halfway through, deduce the values of lambda and mu. Okay, well, what have we worked out previously? We have worked out E to D and we've worked out C to E. Okay, so if E is the midpoint, then CE must be the same thing as ED. C to E must be the same as E to D. So we can deduce from that that C to E must be equal to the vector E to D. Okay, because E is in the middle and clearly they are, we're told E is the midpoint of C to D. Okay, now what was C to E by our previous work? C to E we had as negative a sixth A plus lambda minus 5, 6B. That was this. And E to D, well, we've got this up here. E to D must be negative mu A plus mu minus lambda B. Okay? Now, this is using our knowledge from the previous video. We must have the same lots of A, so a sixth must be equal to minus mu. So negative 6. So negative 6 must be negative mu, i.e. mu is equal to a sixth. And similarly, this thing here must be equal to this here. So we would have that lambda minus 5/6, so lots of b, lambda minus 5/6, that should have a bracket there, must equal mu minus lambda. Now we know what mu is a sixth, so therefore we'd have lambda minus 5/6 equals 1/6 minus lambda, and adding lambda to both sides and adding 5/6 to both sides, just keep on going here. If I added 5/6 to both sides and added lambda, I'd get 2 lambda would be equal to 1, so therefore lambda must be equal to a half. So our two answers therefore for this particular question are lambda must be a half and mu must be 1/6. Quite a tricky question. I'll do one more example and then we'll finish off on this topic. Here's the next question we're going to do. Again, you may want to have a go at this one yourself and check with me afterwards, or you may want the guidance throughout and I'll work through it. In the diagram, the vector from O to A is little vector A. So the vector all the way from O to A, this whole vector here, is little a. The vector from O to B is B. So the vector just from O to B, not the whole thing, that's vector B. We are told also this fact here. We are told that 3 lots of OC, 3 times OC is equal to 2 OA. Okay, now we know OA is little vector A, so in particular OC must be 2/3 OA, and OA is little a, so OC is the vector 2/3 A. Okay, so the vector to get from O to C, just here to here, this portion of it is 2/3 A. Okay, from here to here. Okay, so I'm going to delete that working. You'd leave your working in obviously, and I'm just going to write that as a fact from here. And we'll do another fact from here. We have that 4 lots of OD are equal to 7 lots of OB, and we know OB is little b, so in particular OD must be 7/4 OB, and tidying it up therefore OD must be 7/4 of vector B. Okay, you leave your working in. Again, I'm just going to rub it out for now, and I'm just going to move that up as a fact from here. Okay, so let's just use that information. All the vector from O to D is 7/4 B. Okay, the whole thing from here all the way to here. So in particular, that helps us with this bit. If this first bit is just B, this bit must be 3/4 B. Okay, in order to add up to 7/4 B, because that's 4/4 plus 3/4 would be 7/4. That's 2/3 A. So again, this tells us this must be 1/3 A, this portion here. Okay, so we filled in loads of information from just reading the question properly. We're told DC meets the line AB at E, so DC and AB meet here, and we're asked to write down various things. Firstly, we're asked to write down the vector from A to B. How do you get from A to B? Well, I would go A to O and O to B, so I would say that's A to O plus O to B. Now A to O, the whole thing is A, but we're going in the opposite direction, so it's negative A, and we're going along B. So I'd write that as B subtract A. Okay? And the next part, DC, how would I go from D to C? How would I go from D to C? Well, I'd go D to O and O to C plus O to C. Now, do we know D to O? How do we get from D to O? Well, we know that O to D is 7/4 B, so this must be negative 7/4 B, and O to C is plus 2/3 A. Okay? And we might write that the other way around. We might write 2/3 A subtract 7/4 B. Okay, so we have done this and this now. Right, next, let's keep going. Let's read this fact here. Given that DE equals lambda DC, so DE equals lambda DC, so DE and DC are parallel, and also given the fact that EB equals mu AB. So E to B is mu lots of that. So EB and AB are parallel. Use the triangle EBD, this triangle here, to form an equation relating A, B, lambda and mu. Hence show that lambda is 9/13, find mu. Okay, we are given that DE equals lambda DC. So let's write that fact down. So D to E, let's just keep it on the page there, this one up here, D to E is equal to lambda D to C. So in particular, D to E is lambda multiplied by DC, which is this thing, so lambda multiplied by both bits. So I can write that quickly as 2/3 lambda A subtract 7/4 lambda B, just using that fact. We also know that EB from here equals mu AB. So let's write down what that means. EB is therefore mu times AB, which is this. So it'd be mu B minus mu A. Okay, now, hence we have got something about D, that vector, and hence something about B, E to B, that vector. Let's consider the vector DB, D to B, right? Now D to B is clearly, by the triangle law, D to E plus B to E. Plus E to B. Right? Now what is D to B? Going back that way, it would be negative 3/4 B. So negative 3/4 B would be D to E, which we've got as this thing here. So it'd be 2/3 lambda A minus 7/4 lambda B, plus EB, which is plus mu B minus mu A. Okay, so let's collect all like terms. Let's collect everything up together. Let's leave the negative 3/4 B here. How many A's have we got on the right hand side? Well, we've got 2/3 lambda and we've got subtract mu. So how many A's have we got? 2/3 lambda subtract mu lots of A. And let's do how many lots of B have we got? Well, we've got minus 7/4 lambda plus mu, which I might write as plus mu minus 7/4 lambda lots of B. Okay, let's keep going with this. Now this is like what was in video 2. We've got no lots of A on the right side and some lots of A on the no lots of A on the left side, some lots of A on the right, some lots of B on the left side, some lots of B on the right. For the two sides to be the same, however many lots of A on the left, 0 lots of A must be equal to 2/3 lambda minus mu. That must be true. This must be 0. And similarly, negative 3/4 must be equal to this side. So negative 3/4 must be mu minus 7/4 lambda. Okay, so we've got two equations here. If we were clever and decided to add equations 1 and 2, here and here would add to negative 3/4. The mu's would cancel and I'd get 2/3 minus 7/4 lambda. So 2/3 minus 7/4, if I type that in my calculator, I get negative 13 over 12 lambdas. So dividing both sides by negative 13/12, so negative 3/4 divided by negative 13/12, I get myself 9 over 13 as required. So 9/13. That's exactly what I was asked to show in the question. Hence, find the exact value of mu. We'll just substitute it back into one of the equations. Which equation can I substitute it back into? I could clearly substitute it back into this one. So 0 must be 2/3 multiplied by 9 over 13, subtract mu, add mu to both sides. Mu must be 2/3 multiplied by 9/13. And when you do that, you get yourself 6/13. So mu actually turns out to be 6/13, and we're done. So yes, it was a tricky question, but what you need to do is be exceptionally good with your algebra for these type of questions and label your diagram precisely. Okay, so then just to consolidate this work, do read chapter 5, page 57, and do exercise 5b, attempt questions 5 to 8. They are tricky, but it's worth attempting them just to get your algebra, your vector algebra spot on. Thank you for watching.